Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to my YouTube channel Science for Everyone. Today the video is related to antimicrobial chemotherapy, and the title of my today's lecture is resistance to penicillin. We all know that what basically penicillins are. Penicillins are a special type of antibiotic that acts against microorganisms, and they block the biosynthesis of the peptidoglycan layer of the bacteria. Okay, so first it was introduced in the late 1900s by Alexander Fleming. Uh, he discovered it and he used it against different microorganisms. And as we know that as the time passes by, bacteria shows resistance to uh, penicillins. Okay, so in today's lecture, we will discuss that what type of resistance can bacteria show to penicillins. First of all, I have made many videos related to penicillin and its mechanism of action. I will share the link in the description, and I will also use these links in the I button. So you can watch those videos in order to make a concept of how penicillin works. Okay. I have discussed it in detail, and today I will just discuss the resistance of penicillin. Okay, so a little bit of structure about the penicillin. So this is not the whole structure of penicillin, but it is the main central component of the penicillin that acts against the microorganism. It is known as the structure of the beta lactam ring. Okay, this is the beta lactam ring. So and today's we will discuss the penicillin. Okay, so first of all you should know about the resistance. There are two type of resistance to beta lactam drugs. Okay, there are two type of resistance. One is intrinsic resistance and other is acquired resistance. So in simple, intrinsic resistance means that when the resistance is present in the start of the process, it is already present. Means that for example there is an antibiotic, and when we introduce it in for the first time to a bacteria, and it cannot act against that bacteria, so it is basically intrinsic resistance. As the name as for example, we can say that Pseudomonas aeruginosa, it cannot be killed by the penicillin because the outermost layer, the outer membrane of the Pseudomonas, does not allow the entrance of penicillin into its in periplasmic space. Okay, so for the really first time when Pseudomonas aeruginosa was introduced to penicillin, so the penicillin could not act against it. It was showing resistance to it. And when the research find out that it cannot penetrate the outer membrane layer of the Pseudomonas because it is gram negative. Okay, so basically it is inherited resistance. It is called intrinsic resistance. And the second one is the acquired resistance. Okay, acquired resistance means that for example, we introduce a bacteria to a special type of antibiotic, and the antibiotic can act well against it. And after a few after a passage of time, slowly that bacteria start resistance to that uh, and that antibiotic. So it is basically acquired resistance. For example, for the first time, Pseudomonas aeruginosa was susceptible to carbapenems and imipenems. Uh, but with the passage of time, it start mutation. Okay, and there was mutation in the penicillin binding proteins of that Pseudomonas aeruginosa. First, the penicillin could easily bind to the penicillin binding proteins, and it could act against it. But with the passage of time, Pseudomonas aeruginosa started altering the active site of its penicillin binding protein, and at the last, it shows resistance to it because the penicillin could not bind to it. So basically, this is intrinsic resistance, and other is the acquired resistance. Again, I'm telling you, intrinsic resistance is inherited. It is present for the first time, and acquired resistance is that it is present in the beginning it is not present, but after that it start its action, and the bacteria start showing resistance, and this is due to mutation. Okay, so practically in intrinsic resistance, all strains of bacteria species are resistant to a given antibiotic, whereas an acquired resistance affect only some strain of the bacteria. As I have told you in the beginning, that intrinsic strains will all be resistant to it. And there is intrinsic resistance, so all the strains will be showing resistance to their penicillin. But when, for example, there are two bacteria and both are having the same strain, but when one can show acquired resistance and the other cannot show acquired resistance. Okay, for example, strain A is readily exposed to that antibiotic, so it will show resistance. But if the strain B is not exposed to the antibiotic, so it will not show resistance to it. Okay, so keep these things in your mind. Now there is a this is the overall overview of the six type of resistance that is bacteria show to penicillin. Okay, so the first one is the penetration. Penetration means that it cannot enter the bacteria. In simple, I'm telling you that, for example, our normal body cells, um, the outermost layer is totally resistance to the entrance of the mm, penicillin. Okay, so penicillin cannot enter our normal human cells. So if bacteria is present inside our normal cells, so it is difficult for the penicillin, the beta lactam drug, to enter our cell. So this is the first reason the bacteria can enter our cells and they can hide themselves, and the penicillin cannot get entry to the bacteria. Okay, the second one is the porins. Okay, porins, basically these are special type of channel proteins that is present in the outer membrane or the cell membrane of bacteria. Okay, so in case of gram positive bacteria, there are no porine proteins. Basically these are channel proteins, so there are no channel protein, and the penicillin can easily get access to the peptidoglycan layer. But if we look to the gram positive bacteria, so gram positive bacteria is basically beta lactam drug must breach this membrane by diffusing through these porins, which are protein channels in the outer membrane. But many gram negative bacteria have porins that do not allow passage of certain beta lactam to the periplasmic space. Okay, so this channel protein does not allow the entrance of the penicillins, and it is also such type of resistance to the penicillin. But it is only present in the gram negative bacteria. It is not present in the gram positive bacteria, and it is why it is not present in the gram positive bacteria, because there is no outer membrane. Okay, and so there will be no channel protein, and the peptidoglycan layer is exposed, so it can easily work against it. Okay, the third one is the pumps. Basically it is known as efflux pumps. Okay, efflux pumps are special type of pumps that are used that are used to take out the antibiotic. For example, an antibiotic is present inside the bacteria, so with the help of the efflux pumps, bacteria can throw it away. Okay, it can throw it away. So it is also such type of penicillin. Bacteria can show these such type of resistance to it. The fourth one is the penicillinases. Okay, many bacteria, both gram positive and gram negative, make beta lactamases, enzyme that degrade beta lactam rings. As I have shown you in the first slide, that this is the basic ring that is acting against the microorganism, and how it is acting, I have made videos over it. You can watch it in the later, that how it is acting. So the main purpose of the bacteria is to degrade or to just destroy this ring. So there are such type of enzymes that are known as penicillins or beta lactamases that are manufactured by bacteria, and they kill or they destroy this ring. So if there is no ring, beta-lactam ring, the penicillins cannot act against it. The beta-lactam rings, so the beta-lactam drugs cannot act, and they can lose their function. So it is also such type of mm, resistance. Okay, the fifth one is the penicillin binding proteins. Basically, penicillin binding proteins are transpeptidase proteins that are working uh, that are working in the biosynthesis of the peptidoglycan layer. I have already mentioned these proteins in my videos. There are such type of protein, just like we can say alanine racemase, alanine ligase. These all enzymes are, proteins are acting in the biosynthesis of the peptidoglycan layer. So in short, these are known as penicillin binding proteins. Okay, so the penicillin will bind to them and they will destroy that protein. They will just stop their function in the biosynthesis of the peptidoglycan layer. But what does the bacteria do? They modify their penicillin binding proteins, okay, by making mutation in their DNA, and these proteins can be modified and the penicillin cannot bind to them, and the bacteria can easily show resistance to it. So basically this is also such type of resistance. And the last one is the peptidoglycan layer. Most of the not most, but chlamydia, sorry, mycoplasma, such type of bacteria, they do not have penicillin. Okay, sorry, they do not have peptidoglycan layer. So if there is no peptidoglycan layer, so how can the beta lactam drugs act against it? Because beta lactam drugs can only act against the biosynthesis of the peptidoglycan layer. So if there is no peptidoglycan layer, they cannot act against it. So if someone asks you that either mycoplasma can be killed by penicillins or beta lactam drugs, so your answer will be a big no, because there is no peptidoglycan layer. And one point about beta lactamases is that some are specific for a few beta lactam antibiotics, whereas other have activity against nearly all beta lactam agents. Okay, there are such type of bacteria that they are having their penicillin binding proteins can all be blocked by the penicillin. But most of the bacteria have such type of penicillin binding proteins that nearly not all the penicillin can be blocked. Penicillin binding proteins can be blocked by the penicillin. For example, if a bacteria have 50 penicillin binding proteins, so there are such bacteria that all the 50 can be blocked. But there are such type of bacteria that only 10 to 20 can be blocked and the other cannot be blocked. Okay, so keep this thing in mind. Basically, whereas the extended spectrum beta lactamase is made by some strand of E. coli and Klebsiella species degrade nearly all penicillins. Okay, as sorry, I was telling you about the beta lactamases. Okay, that if beta lactamases can act, they destroy the beta lactam ring. Some bacteria have beta lactamases that can destroy all type of beta lactam drugs. For example, if it is penicillin, if it is imipenem or carbapenem, but there are some bacteria that can only act against specific type of beta lactam drug. Either it could be penicillin or it could be carbapenem or monobactam or such type of other. Okay, so this was a general discussion about the resistance to penicillin. In the later videos, I will discuss about the classes of penicillin, that what are basically the classes of penicillin: natural penicillin, staphylococcus penicillin, aminopenicillins, and aminopenicillin plus beta lactamase inhibitors, extended spectrum penicillins, and extended spectrum penicillin plus beta lactamase. So these are 6 classes of the penicillin. I will discuss each and every in detail. that what are their function and which can act against which bacteria. Okay, so that's all. That is all for today. And if you have understand this lecture, this discussion, so like this video, share it with your friends. You can also add comments to this lecture. Okay, and please subscribe to my channel for more interesting videos related to antimicrobial chemotherapy and microbiology. Thank you very much. God bless you.